Hello everybody. So far we learned a lot about trig functions, right? Now we're going to talk about transformations. So the big picture of this is you essentially start with basic sine, cosine, or tangent graphs. Then you make changes to it. So let's first review those basic trig parent graphs first. The basic cosine curve has an equation of y equals cosine of x. And it has that periodic or cyclical behavior where it repeats the wave over and over again. And it completes its one cycle that repeats in a period of 2 pi. And that's why when we drew the graph, we labeled 2 pi a part of the curve. And the important values on that cosine curve, the points, are cut into 4 parts. And that's why we label our x-axis in 4 increments. Now, one of the key values would be the starting point. And cosine curve starts at the maximum, which is a y value of 1. And we're going to call this capital letter M. And then it goes down, going through the midline, which is the x-axis. The midline is right in the middle. And it goes to touch the lowest point, which we're going to call with the lowercase m the minimum point. And it goes back up. So it has that U shape to it. The sine graph is quite similar. It has the same period as 2 pi. And of course, it's also periodic or cyclical, has that wave that continues. And we actually start at the midline. The start point is on the x-axis, which is also the midline of our basic sine curve. And then it goes up to touch its maximum, which we again label with capital letter M. And it goes down and touches the lowest point, which we call the minimum. The amplitude is the same, it still has a height of 1, and the important values of that sine curve, which has that S shape, it is also cut into 4 parts. And that's why we usually labeled our x-axis in 4 increments. So the last one is a tangent curve. Ooh, this was a weird one, right? Because it had a bunch of asymptotes. Well, this tangent curve is still considered periodic or cyclical because this shape of that tangent curve will repeat over and over again. Now, there are still important values to our tangent curves, and these are also separated into 4 parts. And they are actually separated by pi over 4 radian. So this will be negative pi over 4, 0, pi over 4, and the last ones will be at asymptote, which is pi over 2 and negative pi over 2, right? And this one full cycle, this time is going to be just 1 pi radian, which is slightly different from our sine and cosine. Lastly, the tangent curve does not have an amplitude, right? Because it's the height from that midline, which will be the x-axis, to our maximum minimum. But in this case, there is no maximum or minimum. Therefore, there is no amplitude. So the transformation starts by looking at these variables a, b, h, k, which we call parameters. Now, I have a formula on how to graph transformation for trigs here, but hopefully this should look slightly familiar to you all because we actually have done this before when we're transforming different parent functions, right? Like quadratic, cubic, absolute value, all of these, we were using these same parameters. A was the stretch factor, H was a horizontal shift, and then K was a vertical shift going up and down. And we said HK is the critical points. So the transformation we're going to be doing today depends on what changes you make to the equation itself, like cosine, sine, basic equation. We're going to make changes to those. And it will also tell us how it will change the graph of these functions. So you really need to get a really good understanding of these basic parent functions of cosine, sine, and tangent. So you need to memorize these. So the start of trigonometric transformation is understanding these parameters A, B, H, and K. A is generally the stretch factor, and it's the vertical stretch or shrinking factor. But what's special about it is it determines the amplitude of our trig functions. It's actually the absolute value of A because amplitude is a distance. It's a distance between the midline of your trig functions and to its maximum or the minimum. Therefore, the sine curve had an amplitude of 1, and the cosine curve was amplitude of absolute value of 1, which was equal to 1. Now here is an example graph. 3 sine of x. In this case, this has an amplitude of absolute value of 3, which would be 3. Therefore, as you can see here, from that midline to the maximum point of the curve has a height of 3. And that will be the amplitude that we determine. The next one I want to talk about is the horizontal shift. Horizontal shift is very similar to what we have done before, the h value. But remember, when we had a parabola that was x minus 3 squared, we said that h value is considered a positive 3, so this is when we move right 3 units. But if this was x plus 3 squared, we can rewrite that as x minus negative 3 squared, therefore h value was negative 3, meaning we shift left 3 units, right? Then k value is the one where you move up or down, but something special about the trig is that it also determines the midline of our curve. So that's going to be the middle line. So instead of the x-axis, maybe it could shift. Then the last one is that b value. Okay, this is a horizontal stretch or shrink, and this is something new. This guy is maybe the challenging one, but it helps me determine the period of my trig function. Now, if you remember, the period for sine and cosine was 2 pi, right? And the period for tangent function was 1 pi radian. But when we're dealing with transform curves, this period can change, meaning I might have more curves or less curves. So there's a formula, and the formula for sine and cosine, because the one period is 2 pi, it's 2 pi and divided by that absolute value of the horizontal stretch factor, which is b. But tangent, since it has one period of pi, is going to be divided by the absolute value of b. And I've also included the formula for when you're dealing with trig functions in degrees. Take a look at some of the examples down here. So here's one. If it's y equals sine of 2x, it's that red curve. Do you see how it has more curves in that one period, right? And in this case, since the b factor is going to be 2, and my tangent curve usually has a period of 2 pi, but since this has a stretch factor of b, my new period is going to be 2 pi divided by the absolute value of 2, which is the b, and that's going to equal 2 pi. Therefore, that one full cycle of my transform function has a period of pi. So here are a couple more examples. You can pause the video, look at it yourself, and move on, or you can slow down the video to listen in, okay? So starting with the first one on the top left, it's a cosine. The cosine has the a value of the invisible 1. Sorry, I'm going to label this a. The absolute value of 1 is positive 1, therefore my amplitude is 1. And as you can see in the curve from that midline x-axis to my maximum is a unit of 1. Now the period has changed because now I have a b value of 3. So then I need to do that formula of 2 pi divided by the absolute value of b, which in this case is be 2 pi divided by absolute value of 3. Therefore, my period is 2 pi over 3. And as you can see, that one full cycle of my new cosine curve is changed. Sine of 2x also has an amplitude of 1. But the period has changed, so 2 pi divided by the absolute value of b, which in this case, b is 2, is now 1 pi, and my graph has one cycle of pi. And the last one is a tangent one, but we're not going to do tangent transformations today, so you can look at it yourself. So what I did now is I wrote down the steps on how to graph transformations, and I am going to review these steps as we do some examples together. Right, so we're going to do the first example, which is a problem from a parent guide. Now, I'm going to walk you through